Okay folks, in this lesson we discuss displacement mapping and also subdivision. We're going to be using a simple cube for this lesson. Let me select it and convert this cube to a polygonal object. Simply select the cube and press C on your keyboard. Also go to Create menu in the Material Manager, Arnold Surface, and create a brand new utility shader and apply it to the cube. Let's run IPR. Open up the utility shader and change the shade mode to Lambert and change the overlay mode to polywire. Now we can see the edges of our geometry in our render. Right click on the cube, go to C4D2A tags and add an Arnold parameter tag to our cube. Go to the subdivision tab. First off, we have the subdivision type, which is non-linear and cat-Clark or cat-Clark. We have iteration, which specifies how many times the mesh should be subdivided. So when the type set to none, there would be no subdivision even if you increase the iteration. When set to linear, as you increase the number of iteration, you are adding more polygons to the geometry without changing or compromising the shape of the geometry. When the iteration is set to 0, there would be no subdivision. When I increase it to 1, we have generated 4 faces based off of each face. When I increase the iteration to 2, we have quadrupled the number of polygon again. Go to 3, we have quadrupled the number of faces again. So each time you increase the iteration by 1, you have 4 times more polygons compared to before. But in linear mode, you keep the original shape of the base mesh. Now let's change the subdivision type from linear to cat-Clark, and immediately we have a sphere instead of a cube. The cat-Clark algorithm is used to create smooth surfaces by recursive subdivision surface modeling. So as I increase the iteration, I am not only adding more geometry, I also make the geometry rounder and smoother. Let's set the iteration to 3 here. Then we have adaptive metric, which allows us to have some level of adaptiveness in our subdivision levels. So for example, based on how close or far you are away from your object, you can have more or less iteration applied automatically. At the moment, it is set to auto, and as I increase my pixel error to 20 and run the IPR again, you can see we have smaller amount of polys. If I get away from my cube, now because we are far away from our cube and we don't possibly need as much detail as before, we are gonna have smaller iteration value and also less polys. If I get closer to my cube and run the IPR again, we're gonna have more iterations and polys again. Okay, let me get away from the cube and rerun the IPR. And as I decrease the adaptive error value, we are gradually decreasing the adaptiveness, and at 0 we basically have no adaptiveness no matter what. Now let me get a bit closer to the cube again. Also, we have 2 adaptive modes beside auto. We got edge length and flatness. When set to flatness, the curvature of the mesh in pixels is the feature used to choose the adaptive subdivision level. When using edge length, the length of the polygon edges in pixels is used, and when set to auto, flatness will be used when no displacement map is applied, and edge length will be used when a displacement map is applied to the mesh. Then there is the adaptive space with raster and object modes. Raster corresponds to adaptive subdivision in raster space, and object corresponds to adaptive subdivision in object space. Now, when instancing, you should use the object mode, and when you have only one object, the raster mode will work. You probably don't need to change this option unless you have some instancing going on in the scene. Also, you can read about this option in the Arnold support website and see what they are doing exactly. We have dicing camera, the camera to use when determining subdivision level during the adaptive subdivision. So if you have a camera in your scene, you can specify that camera here, and this way that camera will be used during subdivision calculation for adaptive subdivision that we discussed earlier in this lesson. So basically, when you have adaptive subdivision going on by increasing your pixel error more than 0, in order to avoid any flickering introduced by the motion of the camera, you can specify that camera in the dicing camera parameter, and that way avoid any flickering. Because you imagine you have a moving camera that moves from one place to another place during, for example, one frame. So basically, based on that motion, you're changing the viewing angle in each frame. So basically, the adaptive subdivision need to change and need to add more subdivision in some places, maybe decrease or increase the amount of iteration based on the new viewing angle in this frame. That would cause some flickering, and using the dicing camera you can avoid that. Now, use this parameter sparingly. If you saw some flickering based on your camera motion, try using the dicing camera and put your camera in this field here, and it might solve the problem. Then we have the UV smoothing, which controls the algorithm used to smooth the UV vertices in the mesh when you are subdividing it. Pin corners pins the corner of the UV, and the rest of our UV might move as we subdivide our mesh. Pin border will pin all the edges of our UV. Linear will pin everything, so the UV will stay as it was before subdividing, and smooth will basically move the UV vertices as we subdivide our mesh, so no pinning basically when you use the smooth mode. Also, if you noticed faceting happened in your specular highlights when you have anisotropy, you can enable this option called smooth tangents to get rid of the facet look by enabling this option. Now we have this foundation about subdivision. Now let's discuss the displacements mapping, which allows you to create real geometric detail based on a texture. The difference between displacement mapping and bump mapping is bump mapping was just an illusion. We wouldn't alter the geometry. But displacement mapping actually creates and alters the geometry. Now let me show you how to add displacement mapping to your shader. Let's start by creating a new standard shader. Rename it to displacement map. Now open it up and open the network editor for this shader. As you can see down here, we have the Arnold displacement port. On the left side, let's search for displacement, and we have two displacement nodes, normal and vector displacement nodes. Normal displacement map is the more traditional one when you have a grayscale image and you want to add displacement based on that grayscale texture. But vector displacement can displace the mesh in different directions beside only up and down that we have with normal displacement. Let's drag a normal displacement node and connect it to the displacement port. The next thing would be to define the grayscale image which we want to drive our displacement mapping with. So select the normal displacement node and press Ctrl, Shift, and T. And let's load this DISP32 map, which is a 32-bit grayscale image. Also apply the displacement shader to the cube and run the IPR. The amount of displacement map is too much, obviously. That's why we see nothing relative in our render. Select the normal displacement node and decrease its scale which is the amount of displacement map, to 0.1. Obviously, we don't have enough subdivision to get enough detail. So select the Arnold parameter tag and increase the iteration to about 6. Now I can close network editor and the shader and move around. Maybe get closer here and move around. I can increase iteration number to get more detail or decrease it to decrease the overall detail. Let me just set it back to 6 here. Now if I wanted to preserve the cubical shape of my base geometry, I can change the subdivision type to linear. When we do that, there is something wrong with the displacements mapping. If you go to your displacement tab of the Arnold parameter tag, you have a parameter called bound padding. Padding defines how much to extend the bounding box of the object so that it can include any additional displacement coming from the displacement shader. So when the padding is set to 0, because we don't have big enough bounding box, we see this artifact in our render. By increasing the padding and extending the bounding box of our geometry, we'll be able to get our displacements mapping the way it's supposed to be. So you can use this value really sparingly. When 1 works, never go to 2. This will increase your render time. So here, let's put the padding to 1. And as you can see, we have a beautiful render. And if I want more detail from my displacements map, I can increase the iteration, but keep in mind that will increase the number of polygons heavily. So make sure you use the right number here. If I get back to my shader network editor and select the normal displacement node again, scale controls the amount of displacement map. So if I go to 0.2, we are going to get a larger displacement map. If I increase this value, as you can see, we are basically increasing the effect of our displacements map. Also, you can use negative values here, which will invert the effect of the displacements map. Let's get back to 0.1. Always remember to use a 32-bit image when working with displacements map to get the right amount of detail and to be able to use negative values. Also, if the image is not remapped. Then we have scalar 0 value, which is applied as a shift to the displacement amount. It defines the value of the displacement map that is considered to be 0 displacement map. Now by default it is set to 0, so the black values of the texture are not going to get any displacement. So 0 displacements basically. And everything brighter is going to displace to the outward direction. When set to 0.5, so 50% gray will be 0 displacement map. Darker values in the texture will be displaced inward and brighter values will be displaced outward. And when set to 1, white pixels will have 0 displacement and darker values of the texture will be displaced inward. Let's set the scalar value to 0 again. Also, let's select the Arnold parameter tag that apply to our cube and see what other displacement related parameters are under the displacement tab. We have the height, which is like the scale value in our shader, and it controls the amount of displacement mapping in conjunction with the scale value. Let me decrease it to something like 40 centimeter. And as you can see, we have now smaller displacement effect. We discussed padding. We have another scalar 0 value which works like the one we have in the shader. I recommend not to use this scalar 0 value. Instead, use the one in a normal displacement node always. We have auto bump, and as soon as I enable it, as you can see from the IPR, we get more details. Auto bump puts the high frequencies of a displacement map into the bump attribute so that you don't need as many subdivision iteration values to get that very small high frequency details. And I suggest to have it turned on to get higher quality displacements mapping, especially with normal displacements mapping. Also, we have vector displacement node. Let me hide my cube object and create a plane object. Change its height and width to 50 centimeters. and let me position it in the scene. Also, let me just move my camera and position it a bit. Create a new Arnold standard shader and rename it to vector displacement. There you go. And open its network editor. Let me search for displacements map and drag a vector displacement map to the work area and connect its output to Arnold displacement port. By the way, if you don't see this port, simply click on the red corner of the main group and you can find all the available ports including Arnold displacement. Simply click on it and it will be added. Also select the vector displacement and press Ctrl, Shift and T. Select the vector displacement attribute and load this ear texture. So when you use vector displacement node, remember to connect the texture to vector displacement attribute, not the displacement attribute that we have here. Let's apply this shader also to our plane. There we go, and let me just run my IPR. There is nothing particular in the render. Let me stop the IPR, select the plane and convert it to a polygonal object by pressing C. Add an Arnold parameter and go to the Subdivision tab and change the type to cat clerk and increase the iteration to about 5. Now we are ready to see some displacement map, but if I run IPR again, we still get nothing. Let's get back to our network editor and see what is going on. We mentioned the difference between normal and vector displacement. In normal displacement, we only have two directions, up and down. So we can raise the geometry or lower it, but we can't move it in any other direction. But with vector displacement, we can actually move our geometry in different directions. Now let me select my vector displacement node, change the vector encoding to signed and the vector space to tangent because that's the way I generated this ear displacement texture. Change the order to X, Z, Y and enable flip Z option. Also reduce the scale to 0.1. Scale here also controls the amount of displacement map like we had with normal displacement. Also select the Arnold parameter tag and under displacement change the padding to 1. Now as you can see, we have a perfect ear geometry in our scene. Now let's discuss different parameters that we have in the vector displacement node. We have displacement, which is like the scalar 0 value in normal displacement node. We have scale, which controls the amount of displacement map. As you can see, higher values that increases value yield stronger effects. We have vector encoding, which is signed and absolute. Now absolute is for 32 or 16-bit images and signed for 8-bit images. In this case I have a 32-bit image, so I can use absolute mode, and as I do that, let me just move the camera a bit so I have the right angle. So there we go. Very similar results. I can go back to sign if I wanted to. Let's do that and relocate the camera. Also, let me change the scale to 0.15 here. Then there is vector space, world, object, and tangents. So based on how you generated the displacement texture, originally you can choose your desired coordinate space here. We have tangent, which is the input attribute for connecting a tangent-based vector displacement. You can change the channel orders here and flip different channels. I wouldn't be able to cover every little detail practically here. It would go on forever, but I refer you back to this tutorial on Arnold website, which explains the workflow from scratch, how to generate vector displacement maps in Cinema 4D from and basically how to apply them. It's called Rendering Displacement Maps from Cinema 4D. There we go here. under the common workflows, shading, displacement examples. Now, I recommend that you read every page on this support website. It has some very great tips. If you don't have time, this series of tutorial from mographplus.com will cover the foundation of Arnold in a very well-structured manner. But in any case, please read this common workflow example. There are some very great examples that are very useful, and you're gonna learn how to use these different attributes and options and shaders and stuff like that. Read these common workflows. There are some great tips here. So basically, that is about subdivision and displacement mapping, and I will see you in the next lesson. Thank you for watching this tutorial. It was a free sample from our course Comprehensive Introduction to Arnold for Cinema 4D. Make sure to visit our website mographplus.com and check the entire course out. See you next time.